This is Polymer Physics 350, Homework 7, Problem 1. We consider a long Teflon rod, which is a dielectric cylinder, and imagine that we set up a permanent polarization such that K, some constant, times S, the distance away in the S-hat direction, is our polarization. And we neglect end effects because it is long. First we want to find the bound charges, the surface charge and the volume charge, which are found using these two equations here, these two dot products. And when we plug these in and do some math, we find that the surface charge is just K times the radius of our cylinder. And when we do the volume charge, we find that it is -2 times our constant K. We need to know that these units of K are correct, otherwise how do we know what K is? And we see that if the volume charge is -2K and our volume charge has units of coulombs per meters cubed, then K must also be coulombs per meter cubed because 2 is unitless. For part B, we want to use these bound charges and Gauss's law to find the electric field inside and outside. E outside just is E dot dA, where E is Q enclosed over epsilon naught. Q enclosed we can find by taking the surface and the volume charges and multiplying by them by the area and volume respectively, and we find that the Q enclosed is 0, so it becomes 0 dot dA, which is just 0. So the electric field outside is 0. The electric field inside, which is more interesting, E dot dA again. There's no surface here because we are inside the cylinder, so we just use rho times V, the volume, and we find that the Q enclosed is this. When we do the integration, we can pull out E because it's constant inside the cylinder, and we find a -Ks over epsilon naught S hat for our electric field. In part C, we want to find the electric displacement field inside and outside. To do that, we have this little formula here from Griffiths, where epsilon naught times our E field plus the polarization gives us the displacement field. Outside, we just have epsilon times 0 plus our polarization, so we just get our polarization, which is Ks S hat from way up here. For inside, we just have our E field inside times epsilon naught plus our P, which is Ks S hat, and we end up with a -Ks S hat plus a Ks S hat, which gives us 0.